Shall we start? Are we all ready? This is our session number 3 of momentum and collision. Is everyone ready for this? Okay. Great. Just write +1 in the chat box. Very good. So everyone, obviously I'll have to switch off the chat so that we all focus on the screen. Okay guys, so I will be now switching off the chat so that you guys focus on the screen, and I will try to keep things slow today as it is new interface, and then you will be able to understand things better. Can I watch the replay after this in 2x to save time? Why are you stating things which are common sense waste? Amal Thomas. Okay guys, switching off the chat. Stop writing things on the doubt panel which are not your doubts. Okay, so guys, this is our session number 3 on momentum and collision. In the previous session, we only spoke about impulse, so not much of theory was covered. In the previous one, we solved a lot of problems. Okay, so impulse is basically when a large amount of force will act for a very short duration of time, or a force is acting for any duration of time for that matter. But if specifically for a short duration of time, if a force is acting, then we'll call it an impulsive force, or rather, impulse becomes useful as a term only when. Okay, so impulse can be found mathematically or numerically by product of force acting for a duration of t, or just by finding the value of change in momentum. Okay, apart from that, if you have a graph between force and time, area of that graph will give you impulse, which is also the change in momentum. Okay, so quickly solve this question. We solved kind of same question last time also. We have a cricket ball of mass 0.25 kg which is moving towards the batsman with speed 10 meters per second. Batsman hit it and it returns with the same speed, that is in 0.01 second. Same speed के साथ ball will be returned, which is 10 meters per second in the opposite direction. What will be the value of the force exerted on the bat? By the way, the force which is exerted on the bat by the ball and the force which is exerted on the ball by the bat, they are action-reaction pair. So either you calculate the force on the ball or on the bat, it means the same thing. Giving you guys 60 seconds for this, and the time, 90 seconds, starts in 3, 2, and 1. Come on, people, giving you 90 seconds, okay? Much more than what you should be asking for. Forty-five seconds remaining, half time gone, half time remaining. Come on, people. $20 seconds remaining now. Okay, last 5 seconds, come on. Well done, very good. Okay, so guys, see this. If we want to find out the force, we just need the change in momentum, and the time is already given. So mass into final velocity minus initial velocity upon the time taken. Just a second, guys. Yeah. So mass of the ball is 1/4 of a kg. 0.25 is 1/4 of a kg. Okay, and velocity initially was 10. Later it is also same magnitude, opposite direction. So if final is 10, initial is minus 10 divided by the time, that is 10 to the power minus 2. Okay, so 1/4 into 100 into 100. So 4 cancels it 25 times. What just happened? This is not 100. My bad. 10, 10, 20 होता है यार, क्या कर रहा है? Okay, so 500 Newton is the answer. That's your force. Okay, guys. So things which were done earlier, we have just refreshed the concept of impulse, calculating the force from there, and now today we'll finally talk about the most important part of this entire series of sessions. We'll be speaking about something called as collisions. Okay, now what exactly is collision is something which is very easy to perceive. Whenever things hit to each other, that is where the idea of collision comes into picture. But we want to actually think about it more technically. So whenever two things will collide with each other, the first thing that you should notice is most of the time the objects when they collide, they actually come in physical contact for a very short duration of time. They definitely come in physical contact. They apply reaction force or normal force on each other, and in that time when they actually collide for a very short duration of time. So the force which acts on the two objects is impulsive force. Okay, because the force is acting for a very short duration of time. In this duration of time, if you speak about the two objects which are colliding with each other, if I have to take an example, I will take the best thing that I can think of is the situation when you are playing a carom board game, and this ball is being hit by, the red ball is being hit by the blue ball, and this is the point of contact, and the force on both of them will act in this way. That wherever the point of contact is, if you draw a tangent along the point of contact, the two forces that you're experiencing or the two objects are experiencing are the forces which are action and reaction. So the point is, guys, when the two objects are going to collide with each other, they will experience impulsive forces individually, but overall, we can say that the net force acting is always going to be 0. And when net force always, when a system has net force from outside acting is equal to 0, we can always say that the net momentum of the system will remain constant. That means what? Collision. As I said, when we studied session number 1, I told you guys, the law of conservation of momentum will have broadly 3 applications. The first one I told you was the collision one, which is the most important one, which we are studying here. The other 2 are your explosion and object lays over another object when it was moving. So now we are going to in detail speak about this. So first thing that you will always remember, doesn't matter how collision is happening, different types of collisions that you're going to see. One very primary thing that I want to incept in your mind is to remember, whatever be the type of collision, the momentum along the direction of the force will always remain constant. That means the momentum will remain conserved. Is the first thought that you always have to keep in mind. Okay, what exactly is collision? Collision, technically, I've already given you the idea. Technically, it is called the process where momentum is transferred from one body to another, or kinetic energy is transferred from one body to another. Like if you're playing carom board and the coins are placed in front of you, you are going to strike the striker. Striker goes and hits the entire bunch of coins, or maybe an individual coin you're hitting. Coin was initially at rest, striker hits it. After that, coin starts to move. Sometimes striker comes back, striker goes in any random direction. Sometimes striker stops. Multiple possibilities. All in all, the coin gains the momentum, coin gains the velocity, coin gains the kinetic energy. So that is one of the types of collision which happens. So remember, collision is basically a process of transfer of energy and momentum from one body to another. Right, everyone? So as we proceed, we'll speak about 3 different types of collisions. 3 different types of collision based upon what happens during the collision. Okay, guys. So first of all, the basic understanding of collisions. Okay. Yes. So so the types of collision, as I said, that collisions are basically the transfer of momentum and energy. We will speak about three types of collisions. Okay, three types of collisions. Right now, I'm only, in the tabular form that you see here, I'm only giving you the, technically how you define elastic, and third type of collision, which is given as perfectly inelastic collision. Okay, so these are the three types of collision which are named in front of you guys. First one, elastic collision, and at times you will find them to be called as perfectly elastic collision also. So it means the same thing, elastic or perfectly elastic. Second one, I usually call this as second one, perfectly inelastic collision, or perfectly inelastic collision. And second one, which is written here, I call it the third one. It's called inelastic collision, or I will give it another name that you may find somewhere else also. Or they are also called as partially elastic collision. After some time, you'll get the feel of all three of them. So just wait and watch. I will give you the entire understanding of this. Okay, so this is either called inelastic collision or partially elastic collision also. Okay, so first one, second one, and in the middle, the third one. Let's also go through their bookish definition. The bookish definition says that in elastic, or the first collision is the elastic one. In this one, the collision will be said to be elastic if the total kinetic energy before and after collision remains the same. Means what? If you talk about the two objects which are colliding, you talk about the kinetic energy of the first object, kinetic energy of the second object before collision, before they even collide. That means kinetic energy of the coin placed on the carom board, kinetic energy of the striker before they collide. Okay, so this is the calculation you do. After collision, when they get separated, they move randomly. So just after collision, what is their individual kinetic energy? Find that and add both the values. So overall for the system, the initial kinetic energy and the final kinetic energy before the collision and after the collision must remain the same. That is the fundamental definition of elastic collision. Can this practically happen? No, it's an ideal case. It practically does not happen. Why, everyone? Why it cannot be practically happening? Because when two things will collide, definitely there will be some loss of energy in the form of sound or heat or permanent deformation also. Right, everyone? So that is why perfectly elastic collision or simply elastic collision practically does not happen. Right. Second one is this, right? So perfectly inelastic collision. This is very interesting. First of all, understand a perfectly inelastic collision is the one where two bodies which are colliding, the two bodies which they collide, they stick to each other. They become one body. So if M1 mass is coming, M2 mass is coming, they collide, they become M1 plus M2 mass, and they both move together in a given direction. So that is must to be remembered kind of important information. Okay, and this is practically possible, by the way. Okay, in fact, a few days back when we were solving a question where there was a block and a bullet was fired, the bullet hits the ball fell, bullet also fell. IIT Advanced 2011 question we did. In that, maybe bullet hits the ball, stays inside the ball, and both of them fall downward together. That will become a perfectly inelastic collision. Okay, what happens here? Maximum loss of kinetic energy happens here. Means whatever be the energy possibly losing in any case, if it is a case of perfectly inelastic collision between two bodies which are colliding by different possibilities, if they happen to become a single body of mass M1 plus M2, that is where the system has lost the maximum kinetic energy. Okay, third one is the most practical case, and obviously the least studied one in JEE preparation, because you require a lot of practical data when you study things which are not ideal or which are more practical. So collision is said to be inelastic or partially elastic if the total kinetic energy does not remain constant, but it is also not the maximum lost quantity. Okay, guys. Now, depending upon how the two objects are moving before and after the collision, right? First type of collision is when your object is going in a straight line along x-axis, the other object is also moving along x-axis. They both collide. Maybe they are moving in the same direction. That is also a possibility. So if the two objects are moving in the same direction, they collide, and they still move in the same direction. That's called one-dimensional collision. Okay. So such collision will be called head-on collisions, which practically has to be understood as similar to this diagram that you saw. The two objects when they were colliding, if the collision says that their velocities are along the line of joining their centers, if before collision and after collision they move along the same line, they can come back on the same line, but if they're moving on the same line, then the collision will be called head-on. But if after collision they move like what happens in carom board, striker goes in one direction, coin goes in the other direction, that is basically called as the oblique collision. So on the basis of direction, you can say 1D collision or head-on collision or 2D collision, oblique collision. 3D collision is basically out of picture. We will not be discussing that, not in our syllabus. Okay, I hope the feel of it is clear to everybody. After basic feel is clear to everyone. Nothing mathematically has been studied so far. We will get into the mathematics of it. Okay, cool. Sir, if elastic and perfectly elastic collisions are same, then why can't inelastic and perfectly what? अरे पढ़ने नहीं दिया मैसेज यार. सर मेरा नाम याद है क्यों भाई? नाम बदल के आए हो क्या? Antriksha. That's a boy? Good. Has happened a lot of times with me. No problem. So, Antriksh, I would say. Antriksh, have you ever played carom board? When you play carom board, the striker goes, hits a coin. You must have seen them move in different directions. Means what? Maybe this is coin, this is your striker. After the collide, coin goes here and striker goes here. So when after the collision, they don't follow the same line where they were placed. That collision is called as oblique collision. Okay? Okay. Okay. बात करेंगे अभी तो सिर्फ बेसिक फील दिया है. Okay, we will speak about all of them more in detail. Do not worry. Arshad, in elastic collision में दोनों objects clay ball की तरह चिपक जाएंगे एक दूसरे से और फिर move करेंगे. That's the only thing. Nothing else to be spoken here. Okay. अभी आएगा सब कुछ. We will be speaking about all of them one by one. Do not worry, guys. We are yet to study all of them individually. Okay, it is the beginning. It's not the end of the session. Okay. Yes. So that's a very good question. Now this is the kind of doubt that is good. I would say these two are the possibilities of the previous three cases. That means what? When two objects are colliding, say they collide while moving in the same line. When they collide, after that, if they move on the same line, that is head-on collision. But when they are colliding, there could be elastic collision, inelastic collision, or partially elastic collision. That means what? During this collision, the objects may not lose any kinetic energy as a system. The object may stick together and move together on the same line as a system, and the objects may lose some amount of kinetic energy, but they move along the same line. So the previous three possibility exists for both the cases that you have seen here. Okay, that's what it is. Yes, guys. Okay, everyone. Chalo, don't worry. Have patience. Things will get sorted one by one. We'll speak about all the three collisions in detail. Question for all of you to answer. I will not answer this. A bullet strikes against a wooden block and is embedded in it. Embedded means what? Gets fixed. After it penetrates, it goes inside and stays there only. Then what will you say is the nature of collision in this case? Just a second, let me create the quiz. Okay. Giving you 15 seconds only, and the time starts in 3, 2, and 1. By the way, option A and B are the same options. Elastic is perfectly elastic only. Okay, guys, time's up. Okay. So guys, when two things, say you have a bullet, you have a wooden block, mass m1, mass m2, they collide, and after collision, this line is only drawn to tell you that something happened here, and after that, they become a single body, become m1 plus m2. This is perfectly inelastic collision. Okay, so answer is option D. Now, a quiz for all of you. Another one. A rubber ball rebounds after inelastic collision with the floor. Inelastic means when it collides with the ground, some of its kinetic energy is lost. Which of the following statement is true? Okay, options are there in front of you. Mechanical energy of the ball remains conserved. Momentum of the earth and the ball system remains conserved. Momentum of the ball before collision is equal to the momentum after the collision. Total kinetic energy of the ball and the earth remains conserved. Giving you 30 seconds, and the time starts in 3, 2, and 1. I think I have answered it already before starting the topic of collision. Come on, everyone. Okay. Whatever be the type of collision, the net momentum will always remain constant, which means conserved. The force which is applied by the ball on the earth and the ball, or the force which is experienced by the ball because of earth, will remain the same. No external force, momentum of the ball, earth system remains conserved. Okay, चलो बच्चों, तो अब one by one collisions के बारे में बात करेंगे, and let's try to set some ground rules before we talk mathematics about the collision. Okay, and obviously the first thing that we will study is head-on collision today. Okay, so today we'll be only speaking about head-on collisions. We'll be only speaking about 1D collisions. Yes, yes, tell me. There is for 3D collision, it is not in our syllabus. It is not in our syllabus. All the three possibilities exist for head-on. All the three possibilities exist for oblique also. This is how they are moving on the basis of direction. And this is the possibility of them moving together, moving separately, losing kinetic energy, not losing kinetic energy on that basis. If you will let me teach, then only I will be able to give the examples. No. Is it this is the beginning of the session? Will you let me start the session? Chiranjeeva, will you let me start the session and ask these doubts at the end of the session? Thank you. Yes, Sadiq Irfan, what's your doubt? We'll see. Too early to comment. What's the problem with the batch? Whenever I start a new topic, you don't let me proceed only. You guys want that when sir is teaching ABC, sir should be answering the doubts of XYZ also. We guys have been together since the month of May end. This is the month of August end now. More than 3 months. You understand that sir takes the doubt at the end of the class. I stay for almost an hour after the class. So please hold your horses. The doubts which can wait, please wait. And class teachers, if somebody is asking for you to unmute, please ask them why unmute. Why unmute? And if somebody is asking, sir, can you please show the previous slide? Forward it to sir. Ask them, why do you want to see that slide now? Most of the time, people want to note down the theory. I have said this a number of times. If you ask me to wait for 60 seconds per slide, that means if I'm teaching you guys, say 10 slides, then 1 hour just goes in you guys noting down. You know that we go through at least 50, 60 slides every session. That is not practically possible for you to note down. I have said this in my class n number of times. Saying this once again, you guys don't need to take the theory notes in my class. You just have to note down the important formulas. I will tell you when to not note down the formulas. If you see any numerical application formulas, note them down. Do not take the theory notes parallelly. If you are taking, that's good. Do not ask class teachers or me to go back to the slide for you to note down the theory part of it. I'm being very strict on this. Okay? Thank you. All of you, let me start the session now. Now we are speaking about head-on collision. All three possibilities we will be covering in head-on collision. And that is perfectly elastic, perfectly inelastic, partially elastic. Three possibilities exist in any type of collisions. So this is head-on collision. Means what? If you will have object number 1, which is moving with a velocity u1, you will have another object moving with velocity u2. They are basically moving on the same line. That is when the possibility of head-on collision happens. Okay? So when the two objects are moving and there is a possibility for them to collide, then we say that their collision is going to be called head-on if their centers are lying at the same line. Okay? So whatever will happen with them, this collision is going to be head-on collision. Okay, their masses m1 and m2. Okay, when they're moving along the same direction, definitely the collision will only happen when u1 is greater than u2. If they're moving in the opposite direction, not a problem at all. Obviously, for the object which is coming from behind has to move faster in order to have this collision happening. Okay, now guys, few points that I want to state in the beginning of any type of collision. The first one, as I've already spoken about it, that during collision the linear momentum is always conserved. It is invariably always conserved. Especially later on when we'll speak about more situations, at least you will have to talk about the direction of impact. Direction of impact means you will have to look at the direction in which the force is acting. So that is called as the direction of impact. If two objects are hitting like this, their forces will act along the same line. So the force which are internal forces trying to justify the law of conservation of momentum along that direction, we will say that the momentum is conserved. So when the situation will come, I will specifically spend a lot of time there. As of now, the takeaway is momentum will always be conserved when we are solving a question of collision. Keep a mental note of it. More than noting it down, keep a mental note of this particular point. It's one of the most important point about solving a question from collision is that law of conservation of momentum will always be applicable when you are studying collision, when you are solving anything when two objects are colliding. Okay. Second thing, during collision, which happens for a very short duration of time, the bodies which are going to collide, they will always have impulsive force. I said this, that the forces which are acting for a very short duration of time. That's why the forces will be impulsive. And obviously, may be visible, may not be visible. But when the bodies are colliding for that short duration of time, if you will take ultra slow motion video of their collision, you will find that the two objects deform. These spherical bodies will not look spherical when they are actually colliding with each other. Means what? Say if you just for the sake of visualization, imagine a rubber ball which is perfectly spherical. When you hit it or when you throw it to a wall, it hits the wall. When it is in contact with the wall, it actually compresses. Okay. So any two objects which are colliding during the time when they are applying force on each other, when they are colliding with each other, their shapes will be deformed. When their shapes get deformed, see what happens when the two objects try to collide. Very important it is. When they are trying to collide with each other in this intermediate step, their shapes get deformed. So what happens, guys? Say if I call this body A and this body as B, this is A and this is B, they are colliding, red and blue bodies. So what happens? Body B will be experiencing a forward force because of body A. Body A is coming from behind, so obviously will hit and push the body B further forward. Okay, body B is already there acting like a wall for body A. Body A comes, hits the backside of body B and experiences a force in the backward direction. The point is, both of them apply equal and opposite force on each other. Now the point is, during the time when they are colliding, this is ultra slow motion situation that I'm talking about. Body B has its velocity along the direction of the force. This is the initial velocity of B, right? And if we speak about initial velocity of A, that is also in the same direction. The point is, first focus on B. The force which is acting on B and its velocity both are in the same direction. That means what? Gautam sir, can't you answer that question? Can't you answer that question? मनन चौधरी, इस कार में तुम बैठे हो और इस कार में मैं बैठा हूं, ठीक है? अगर मेरी कार को आके तुम्हारी कार से हिट करना है, तो क्या मेरी कार को तुम्हारी कार से फास्ट मूव करना चाहिए? बिना उसके होगा कोलिजन? दैट इज व्हाई u1 शुड बी ग्रेटर देन u2. ओके? अगर ये ऑब्जेक्ट 10 मीटर पर सेकंड से चल रहा है और ये ऑब्जेक्ट 5 मीटर पर सेकंड से चल रहा है, कभी कोलिजन होगा? दैट्स इट, एज सिंपल एज दैट. You guys are still not trusting me, by the way. I'm still not liking this part. I'm expressing my emotions very frankly to all of you guys. You guys are still asking that out before you should be actually listening to what I'm explaining. This is not the first time you guys are attending a class with me. When I say something is very important today, I actually expect your 100% attention on the screen. And whatever doubts you have, just note them down. You can ask me all those doubts personally. And class will not get over at 9:30 today. It will go till 10 o'clock. Last time I told you guys because I had a meeting, I had to finish up early. Okay? So everyone, when A and B are moving class teachers, no doubts to be forwarded now. No doubts to be forwarded no matter what. Till the time I tell you to forward a doubt, you will not forward any doubt to me now. Till the time I open up for the doubts, you will not forward any doubt. Am I clear? All the class teachers, I want an answer from all of you. Gautam sir, am I clear? Gautam sir, I'm still waiting for your answer. Thank you. Okay, guys. Okay, guys. Point number 1. During collision, momentum of the system will always be constant. Point number 2. During collision, the forces will be acting for a very short duration of time on the bodies. Even when the two bodies stick together, they do not continuously keep on applying force on each other. Okay, so even if there is perfectly inelastic collision, which will happen when the two objects will stick to each other, the force will only act for a small duration of time. After that, they will stick together. Okay, in this process of collision, be it perfectly elastic, perfectly inelastic, or partially elastic collision, the two objects, when they are experiencing force from each other, their shapes will change quite visibly sometimes, quite small amount sometimes, so that it is not visible. So the point is, guys, when we look at the situation drawn above, I'm giving you the diagram of an intermediate step when the forces act on the two bodies, which is the process of collision, which is precisely where they are colliding. So you see that the velocity of both the bodies are towards the x direction or I cap direction. Velocity of body A as well as velocity of body B, both are in the same direction, UA and UB. But the forces which are acting on them individually suggest that body B is experiencing the force which is suggesting that it is going to try to increase the velocity of the body. Means what? If the body is going in a given direction, you also apply a force in the same direction, then definitely the body's velocity will increase. Okay. While for body A, the body is going in the x direction, the force is acting on the opposite direction, so it will retard. So obviously velocity of body A will decrease. Okay, and that is why after some time, if they separate, then the velocity v2 will become more than v1. Then only they will be able to separate. By the way, you can say v1 will be less than v2. Then only the two objects can actually separate when the body which is moving forward starts to move faster, and this body slows down in this process. So this slows down, this speeds up. Now they have separated. Okay, or I should say collision is done. So once the collision is done, now the two bodies don't apply any force on each other. That is why it is a very short duration of process, impulsive process it is. Okay, guys. And third, depending upon the possibility of the objects being able to regain their shapes because they collided, When they collided, their shapes got deformed. Now, whether they are able to regain their shape, whether they are half regaining their shape or some partial amount of regaining of their shape, or third, not at all trying to regain the shape, we try to define the three types of collision. But before we define the three types of collision or study them one by one, we will define a mathematical coefficient which will try to give us the idea of the three types of collision. Okay. Now switching on the chat so that I can ask you people. अब तक story में कुछ doubt है तो अब पूछो. No, frankly, what I don't like, I express my, what should I say, anger only when I'm been interrupted in a topic which I know will require me to speak more. Sir, A का velocity कैसे कम हुआ? A का velocity कैसे कम हुआ ये मैं भी मैथमेटिकली एक्सप्लेन कर दूंगा अर्शद. ये मैं भी मैथमेटिकली एक्सप्लेन कर दूंगा. ठीक है? प्रैक्टिकली A का velocity इसलिए कम हो रहा है क्योंकि A जिस डायरेक्शन में जा रहा है उसके अपोजिट डायरेक्शन में उस पे फोर्स लग रहा है. तो उसको रिटार्ड होना ही पड़ेगा अर्शद. सर सेकंड में वेलोसिटी वाला मैं समझा नहीं. Sir, we throw ball A to ball B. Am I right in this theory? We are not throwing ball A towards ball B. Ball A is also moving, ball B is also moving, but for them to collide, ball A has to move faster. That's it. No problem, Chiranjeevi. Third point, could you, sir, just quickly sum up? Third point is basically not completed yet. Third point is yet to be explained. On the next slide, we are going to talk about that. So, two bodies collide in vacuum with same velocity without any gravity, then there will be no loss of energy. Shivam, you will understand that there is still possibility of loss of energy. Not necessarily that it is gravity which is creating this thing. Deformation is out of shape. Cricket का भी खेला plastic balls है. Plastic ball. Have you guys played cricket with plastic balls? So when you hit the ball very strongly, the ball permanently gets deformed. Shape changes. That's basically deformation. Sir, can the deformation of the object during collision be of microscopic level? Yes, Aditya, definitely. Definitely, Aditya. In fact, when two steel balls will collide, we will see nothing happen. But at microscopic level, the steel balls also get deformed. Rubber ball will show a visible deformation. Steel ball will not show a visible deformation. Sir, is there any case where there are two collisions, one after another? We will speak about that in problems, Gauri Shankar. We'll speak about that. So do deformation do loss in kinetic energy? That's the only energy which is being lost, Monish. That's the only energy which is lost here. Kinetic energy is lost. हाँ बिल्कुल वही पिछड़ जाता है वही डिफॉर्मेशन कहलाता है. सर मींस यू बी विल कवर मोर डिस्टेंस देन यू ए. नो 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 नो. बिफोर कोलिजन A is moving faster, B is moving slower. After collision, B will move faster, A will move slower. Deformation in crockery items, sir. मैं measure करके थोड़ी बता सकता हूँ. कैसे measure करते हैं वो भी बात करेंगे. What if the objects are diamonds? Deformation happens in every object. Every means every object. Whatever you can imagine. Okay. Yes, Jack Ritik, one of them could be at rest. Obviously, B can be at rest also before collision. अभी भी मैं बोलूँगा mathematics is yet to come. Mathematics is yet to come, everybody. Yeah. Okay. Let's go. Let's understand better. Okay, everyone. Yep. Switching off the chat now once again, everybody. Shreyansh, yes, we can also see the deformation of a rubber ball when it hits the wall. It is visible, please. It's not something which is not so easily visible. Or if you make a slow-mo video, you can. Okay, guys, third point. This is where I want to go to elaborate better. So depending upon the material's ability to regain the shape, we will define three types of collision. I'm again going back to them. Okay, this is perfectly elastic collision. Material or objects regain their shapes completely. In perfectly elastic collision, why it is ideal? Because the material is going to regain their shape completely. That is not the ideal part. The ideal part is there is no loss of energy happening. So loss of energy will definitely happen in any collision practically. But for our studies, perfectly elastic collision happens. Okay. The second type perfectly inelastic collision is objects do not even try to regain their original shapes. Permanent deformation is what I would say. They will have permanent deformation. They will become one object and they will have permanent deformation. And the third type is partially elastic or inelastic collision. Okay. Some deformation is left, but objects separate from each other. Okay, there the object will not stay as a single object. They will separate out, but there will be some deformation which will be left. Now try to read their names once again. Your understanding will become even better. Perfectly elastic collision. Okay, this is the perfectly elastic collision where material perfectly regain their shape. Perfectly inelastic collision doesn't even try to regain their shape. Okay, there's one more name for this also. It's also called as plastic collision. Why it is called? We are not going to get into the debate of that. But it is also called perfectly inelastic and plastic collisions both. So because they are not even trying to regain their shape, they are called perfectly inelastic collisions. Third one, where material will collide, will deform, will also gain some permanent deformation also, but not like they are not even trying to separate. Means what? Like the cricket ball being plastic ball being hit by the bat, ball and bat do not stick to each other, but there is a deformation in both of them, especially in the ball. Right, everybody? So that is how the three types of collisions are being defined. Now, how do we measure this, or what is that criteria of defining this possibility of regaining the shape? Is what we call as coefficient of restitution. Depending upon the type of collision, we define something called as coefficient of restitution represented by small e. How do we calculate it? We calculate it as the velocity of separation of the point of contact, or you can say the bodies, divided by the velocity of the approach of the point of contact. Most of the time, that is basically the bodies only. So you will remember the expression or the formula only by this. What does capital E do? It tells you what type of collision is happening. What type of collision is happening? Okay, so let me first of all tell you, I'll come to this formula after some time. I'll tell you what will define a type of collision. If you are talking about a perfectly elastic collision, for that, if you get the value of E as 1, if you get the value of E as 0, or if you get value of E somewhere between 0 and 1, but not equal to 0 and 1, then this collision is called perfectly elastic. Okay, so if you have E equal to 1, that's perfectly elastic collision. Perfectly inelastic collision if E is equal to 0, and last is partially elastic collision. This is mathematically that will help us understand what type of collision is being spoken in a given question. What is velocity of separation? What is velocity of approach? This is something coming from relative motion. If you talk about the two objects here, let me try to make it more mathematical for you to understand. Say there are two objects, mass m1, m2. This person or this body is moving with 4 meters per second. This object is moving with 1 meters per second. Tell me guys, every second, how close they come every second in the chat box? Tell me. Every second the gap between them will decrease by how much? So velocity of approach is basically they coming close. So can I say that if this is u1 and this is u2, you guys are saying it is 4 minus 1, right? The velocity with which they are coming closer to each other is 3 meters per second, which is nothing but u1 minus u2, right everyone? And obviously written vectorially. अगर direction opposite होंगे तो minus plus का ध्यान रखेंगे हम लोग. Okay, and after collision, obviously this was A and this was B. After collision, maybe your velocity v1 of this object becomes say 2.5 meters per second, and this fellow starts to go with say 5 or say 6 meters per second. Some other example maybe. So what will be the velocity of separation? How they will be separated, and how their separation will increase? Can I say it is 6 minus 2.5? That is, numerical value is not useful, but what is important that it is v2 minus v1 vector. Make sense? What is velocity of approach? The velocity with which two objects come closer to each other relatively. And what is velocity of separation? The velocity with which two objects go away from each other relatively. We know that velocity is a relative quantity. Understood? Make sense? Good. So that is how you will find out the value of E. They will not collide. Arey, this is after collision only. This is before collision. Same objects. This is after collision. Anokhe doubts. Mark Zuckerberg. That is what is velocity of separation. If this goes with 6, this goes with 2.5, the gap between them will increase at 3.5 meters per second. That is their velocity of separation. Their separation increases at 3.5 meters per second. Okay? We will never get the value of E greater than 1, and we will never get the value of E less than 0, practically. Yes, so E will always be between 0 and 1. General queries after the class, not now. Can V1 be equal to V2? Yes, Arihant will speak about that case in some time. V1 can be equal to V2. Magnitude of relative velocity, absolutely, you got it right, Jay Kritik. This is what it is. Magnitude of relative velocity it is. But which one is moving faster, which one is moving slow is what you have to understand. बिल्कुल विहान, ये वैल्यू 0 भी आ सकती है. We will speak about that. तो चलो यार, अब बात करते हैं पहले कोलिजन के बारे में. फाइनली अब आ गया है हमारा असली स्टार्ट ऑफ द टॉपिक. ऑलमोस्ट आई कैन से 1 hour is already gone. We have done nothing today. We have solved nothing today. Let's go and solve something. Let's first understand. Biggest disclaimer to all of you guys. What you are about to see is the biggest derivation of your entire JEE plus 11 plus 12th preparation. The lengthiest derivation is coming on the way. It is the lengthiest derivation. Okay, derivation of what? Understand that. The two objects A and B are going to collide perfectly elastically or just elastically. So value of E is going to be 1. Okay, that simply means what? The velocity, if this value becomes equal to 1, velocity of separation and velocity of approach will be equal. Which means what? The rate at which they were coming closer before colliding is going to be equal to the rate at which they are going to separate from each other. मतलब हिंदी में बोलता हूँ, collision से पहले दोनों objects जितना fast एक दूसरे के पास आ रहे थे, collision के बाद उतना ही fast एक दूसरे से दूर चले जाएंगे और जाते रहेंगे. Okay, so everyone, the condition remains the same according to the diagram. U1 is greater than U2. So what is our objective to find out here? Our objective is to find out the velocities of the object after the collision. That means V1 and V2 find out करना is our objective here. ठीक है, everyone. So pay attention. These are the steps that I am telling you that we will be using to find out the value of V1 and V2. As it is collision, and whatever be the type of collision, law of conservation of momentum will be applicable. So law of conservation of momentum is what we will apply first. How do I apply law of conservation of momentum here? I see that before collision, this is where collision might have happened. So this is before, this is after. So before collision, the momentum of the first body is m1 u1. The momentum of the second body is m2 u2. Ideally, I should be writing it vectorially, but because it is one-dimensional collision, it is head-on collision that we are studying today. That's why either the velocity is positive or negative because it is happening everything on the same line. So m1 u1 plus m2 u2 we will put according to their sign, positive or negative. Okay, equal to, this is before collision momentum, and after collision, the momentum of the first body will be m1 v1 plus m2 v2. Collision before momentum will be equal to collision after momentum is what I have written here in front of you. Okay, now what I'm going to do, I'm going to bring m1 wala term to the left hand side and I'm going to take m2 wala term to the right hand side. So I will have m1 u1 minus m1 v1 equal to m2 v2 minus m2 u2. Take m1 common. I have u1 minus v1 equal to m2 taken common. I have v2 minus u2. I doesn't think that anyone will have any doubt here. Just rearranged, take an m1 common, take an m2 common. This is my equation in front of us. Okay, this is my equation number 1 which I had. Okay guys, now as this is perfectly elastic collision that we are speaking about, so definitely the kinetic energy also remains conserved. That was one of the definitions that we studied for perfectly elastic collision. The kinetic energy must remain conserved. So let's write down the energy conservation or kinetic energy conservation. Okay, so everyone, let's write the kinetic energy conservation equations now. So before collision, kinetic energy is half m1 u1 square. बहुत ध्यान से सुनते जाना, everyone just pay attention to what I'm doing. You will understand everything. Okay, you will definitely require to watch the replay of this part, derivation part. Okay, I'm not sure whether it is important from your school exam point of view. It is definitely not, but it is the lengthiest derivation. So half m1 u1 square energy, kinetic energy of first body, half m2 u2 square kinetic energy of the second body before collision. Now after collision, half m1 v1 square plus half m2 v2 square. Now both of them, the terms are equated because kinetic energy remains conserved in perfectly elastic collision. 2 cancelled throughout, and again you will do the same thing. Bring v1 term to the left hand side, take v2 term or m2 term. Sorry, bring m1 term to the left hand side, take m2 term to the right hand side. So this looks like m1 u1 square minus m1 v1 square equal to m2 v2 square minus m2 u2 square. Take m1 common, u1 square minus v1 square. Take m2 common, v2 square minus u2 square. So it is a square minus b square, right? And this also a square minus b square formula, which is basically m1 u1 minus v1 u1 plus v1. A minus b, a plus b. Similarly m2 के बाद v2 minus u2, v2 plus u2. Okay, guys. Why sir is doing so lengthy derivation? You will see it is getting simplified. Have a look at this equation and what we did in the previous slide. m1 u1 minus v1, m2 u2 v2 minus u2. Let's take it to the other slide so that we can cancel out a lot of things. This is coming from the previous slide. This has come from the previous slide. Okay, so see that what I'm cancelling now. m1 u1 minus v1. This whole term gets cancelled with m2 v2 minus u2. Okay, guys. This thing equal to this thing. That's why I cancel out because they're equal. They're same things. That's why. Okay. Now what you are left with is what proves that value of e is equal to 1 for you people. E का value 1 होता है वो मैं prove करने आ गया. So this is going to prove that thing. So bring this v1 back to the right hand side. I'm taking v1 back again this side and I'm bringing u2 here. u1 minus u2 will be equal to v2 minus v1. Therefore e is equal to 1. Velocity of separation and velocity of approach came out to be equal. That's what we did just now. Okay, everyone. From here, what you have got, you will basically be doing the derivation of u1 and v1 and v2. Okay, everyone. So what we have done so far, we have got this, the equation of law of conservation of momentum as equation number 1. This is law of conservation of kinetic energy, equation number 2, and we proved that velocity of approach is equal to velocity of separation. From here, guys, what we have got, u1 minus u2, velocity of approach is equal to velocity of separation. Now, what do I want to find? I want to find v1 and v2. So I'll do one thing. From here, I will write v2 as u1 minus u2 plus v1, taking this v1 to the left hand side. So this is what I get, and I'm going to put this in equation number 1. What was equation number 1? Equation number 1 was law of conservation of momentum. That means m1 u1. Let me change the color for you guys to also understand this. m1 u1 m2 u2 equal to m1 v1 plus m2 v2. So I'm going to do what? I'm going to put v2 here. I'm going to put v2 here and do the derivation part of v1. If I put v2 in terms of v1, the only unknown left will be v1. Obviously, in situation u1 and u2 is given to us is what we are assuming here. Or generally, question will give you the value of u1 and u2. So m1 u1 plus m2 u2, m1 v1 plus. After m2, I'm putting u1 minus u2 plus v1. So this is m1 v1 plus m2 u1 minus m2 u2 plus m2 v1. Okay, guys. So v1 terms will be kept together, and rest you will take to the left hand side. Okay. So see this. So I will be left with first writing these right terms. m1 v1 plus m2 v1 is equal to m1 u1 minus m2 u1. This term goes to the left hand side first. So u1 u1 terms written together. After that, m2 u2 and m2 u2. Okay. So from here, I will have m1 plus m2 into v1 is equal to m1 minus m2 into u1 plus 2 times m2 u2. Now what will I do? I will take this m1 plus m2 on the left hand side, and my final expression will come out as this. This is the final expression that we were getting. Okay. m1 minus m2 upon m1 plus m2 into 2m2 upon m1 plus m2 and u1 and u2 as this. So this is what it is. Please note this down, everybody. Please note down. Very important formula. And I would want you people to actually remember the formula. This is the velocity of body A. The body which was coming from behind. It is the velocity of that object. The body which tries to approach to collide. The one which is moving faster before collision is body number 1. Okay. This is its velocity after collision. This is its velocity after collision. Now, once you have got this velocity, remember this equation, everyone. I hope you guys have noted down what is written in the bracket. Now you will put this back in this equation. v2 equal to u1 minus u2 plus v1. You will get the value of v2. You will put that v1 that you have found over here to derive it further. So we will not do the derivation as of now because it's not important. But I'm telling you how can you try this by yourself also. It is u1 minus u2 plus v1. So you will put this v1 here to get the expression of v2, and it looks very similar. The expression looks very similar for you to memorize it. Note down that formula also now. The expression will come out to be m2 minus m1. In the previous slide, it is m1 minus m2 upon m1 plus m2, and there it was u1. So here it is u2. And it was 2m2 u2 upon m1 plus m2. Here it becomes 2m1 u1 upon m1 plus m2. I'm just writing v1 for your comparison. Only for your comparison, I'm writing v1 once again. It is m1 minus m2 upon m1 plus m2 times u1 and 2m2 upon m1 plus m2 times u2. That was the formula of v1. Okay, everyone, please note down both the formulas, very important. Okay, is the derivation important? I would say no. I would say no. Derivation is not important, especially from J point of view. No, not at all important. From J point of view, not at all important. Are these two final expressions important? 2 years back, I would have said no, you don't need to memorize them. But now I say you need to memorize them because there are times now when J directly asks you the questions where if you know the formula and if you don't know the formula, there is a significant difference of the time that you will spend. So if you know the formula, you can actually save a lot of time in J examination. Okay, guys. Boards are questioning because it is a school examination. They usually don't ask derivations of mechanics much. Okay, cool, everyone. Now, as you guys had many questions, that sir, can first body be moving, second body be at rest? Can both of them move in the opposite direction? Can both of them be of same mass? Let's speak about the different cases. Case number 1, what if the two bodies which are colliding have the same mass and M2 is at rest? That means what? When you're playing carrom board, you are striking one coin with the other coin, not with the striker. You're striking a coin with another coin and head-on collision. So what will happen? Look at the formula. I'll just bring the formulas to you. You will find that their velocities will be exchanged. U2 is given to us as 0, by the way. U2 is given as 0. If the situation is that first body is coming to collide the second body, okay, and this is given to you as 0. So put m1 equal to m2, put m1 equal to m2, v1 will come out to be 0, which is basically equal to u2. Whatever was the velocity of the second body now has become the velocity of the first body after collision. So u2 is equal to 0. So now this becomes 0. v1 becomes 0 after collision. And if you look at v2, this part is 0 anyway. m2 minus m1, m2 minus m, sorry, u2 has become 0. My bad. u2 is 0. This part becomes 0. So here you will put 2 times m upon m plus m. So 2m by 2m cancels. Only u1 is left. So v2 becomes equal to u1. So you can say that their velocities will exchange. So whenever here you have to remember this case, because if you are lucky, if you get a question where both the objects have same mass, if they are moving with the same velocity, two objects of same mass are moving, whatever happens, they collide. After collision, their velocities exchange. If the collision is perfectly elastic, two bodies of same mass will exchange their velocities. Whatever be their velocities before collision, they will just exchange it. Okay, cool, good enough. No need to write down actually. Need to understand. Okay, case two. Case two is when the second body which is being collided with is very heavy and is at rest. Okay, means u2 is still 0. Situation is like, means just to visualize, it is a ball which is hitting a truck. So anything will happen to the truck? Nothing. You see that v2 still remains 0. The ball after hitting a truck cannot make it move, obviously. You can actually try this with this equation also. These equations if you go by. Okay, just a second guys. Yes, so this was 0, this got cancelled. Yeah, now everyone, if you will see this, u2 is 0. So v1, the velocity of the ball after collision, you can see that m2 is very greater than m1. So m1 can be almost taken as 0. So it is minus m2 upon m2. So what we are getting effectively out of it, if m2 is very greater than m1, then we can say that m1 plus m2 is almost equal to m2, right? And m1 minus m2 is almost equal to minus m2. That's the thing. So in this, effectively, v1 comes out to be minus m2 upon m2 into u1, which is minus u1. That means what? Whatever was the velocity of the ball before collision, it has the same velocity, but in the opposite direction. So ball hits the truck, comes back with the same speed, doesn't happen anything to the truck. And that's why v2, if you will check, will come out to be 0. Why? Because 2m1 is very small in comparison to m2. So this overall bracket is almost tending to 0. So that's why v2 comes out to be almost 0. Okay. Okay, guys. So third case, once again, this time the truck is going to hit a stationary ball. Truck hitting a stationary ball. So m1 is going to hit a ball. Ball ka initial velocity is 0. So what will happen to the truck? Nothing will happen to the truck when it is going to hit a ball. So you see that if u2 is 0, this part m1 minus m2 can be neglected because m2 is very small. This v1 is equal to m1 upon m1 into u1, which is equal to u1. That means what? Nothing happens to the truck. Truck has the same velocity as it had earlier. So m1 has same velocity u1 after the collision also. But if we speak about the ball will have almost zero mass or negligible mass. So v2 comes out to be roughly 2 m1 by m1 into u1. So m1 cancels 2 times of u1, which means what? Try to think about it. When a truck is moving and a ball comes in its way, then nothing happens to the truck. Its velocity remains unchanged. But ball will gain a double velocity. Ball will start to move very fast after colliding with the truck. Okay, guys, cool. Do I need to remember the three cases? No. Only case that I want you people to keep a mental note of is the first one. When both the masses are equal, they collide elastically, their velocity exchange. Okay, good enough. Chalo, 2 slides more, then we'll get into problem solving. Okay, we'll speak about the easiest of the collision now, and that is perfectly inelastic collision. I just pray for every examination to ask questions from inelastic collision because they are the easiest of the cases. What happens here, guys? Before collision, situation remains the same. M1, U1, M2, U2, U1 greater than U2, then only collision happens. But after collisions, they become a single body because their coefficient of restitution, E value is 0. Okay, so they stick to each other. The two bodies stick to each other. That's why they behave like a single body moving with velocity Vf. So here, very easy it is. Law of conservation of momentum. We apply law of conservation of momentum. You see, things will be so easy. It is going to be m1 u1 plus m2 u2, and after collision, both the bodies have the same velocity because they are single body only. So what is final velocity Vf? It looks like a formula that you guys have recently learned. The velocity of center of mass. Why? Because the center of mass is not experiencing any external force. That's why the momentum is conserved. And after collision, because they are moving as the single body, so the center of mass is also moving with them. That's why the final velocity is the simplest expression: m1 v1, m1 u1 plus m2 u2 upon m1 plus m2. Done. Story ends there. Okay, guys. Everyone, understood so far? Sir, in the case of two balls of same mass, I tried sometimes both the balls move when I roll. One ball on the other, one does not stop. If I'm not able to understand your question. Shivam, I'm not getting your question. Manan says if V of separation is equal to velocity of person, am I right? Yes, Manan. That's right. Case 1 नहीं हुआ का मतलब दोनों मासेस जब कोलाइड कर रहे हैं और उनके मासेस सेम हो, अगर दोनों के मास सेम हो, मैथमेटिकली समझ में आया या फील नहीं आ रही इस सिचुएशन की? सॉरी, हाँ, u1 u2 को 0 किया मैंने, तो ये वाला टर्म 0 हो गया, बचे हुए टर्म में m1 इक्वल टू इनटू पुट करो. ओके, Sir, these cases are under friction or frictionless. We are assuming things are happening under frictionless condition because friction will be an external force, momentum will not be conserved then. Okay, guys? Okay. Guys, general knowledge questions, please keep it for the end of the session. Again, repeating. Sanket, right in front of you, दो objects before collision, after collision momentum, after collision दोनों चिपक गए, so their final velocity is m1 u1 plus m2 u2 upon m1 plus m2. Okay, Karthik, then the cases will not be studied under law of conservation of momentum if there is friction also present. ठीक है? And by the way, things not necessarily collide only on the surface. They can collide mid-air also. हवा में भी collisions हो सकते हैं. Yes, Manam. Guys, friction वाला case discuss ही नहीं कर रहा हूँ because that is out of our discussion. Yes, Manam. अरे okay fine. हाँ. I will unmute you. Why will I not? अरे दो हवा में बहुत कोलाइड कर रही है विहान. अब उसका एग्जांपल क्या बताऊं? क्वेश्चंस में एग्जांपल मिलेंगे ना. शिवम, your microphone is not working, बच्चा. Siddharth Gautam says, sir, is a person jumping on the skateboard and they both start to move together as an example of perfectly elastic collision? Yes, perfectly elastic collision it is. Okay. 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 Vishesh, not necessarily. Your doubt, तुम्हारे doubt का answer है not necessarily. Switching off the chat because I can see now people are just wasting time on the chat box. Chalo guys, example for all of you. Question number 1 it is for us and it is a detailed question, so pay attention. Question says that we have a block of mass 5 kg which is moving from left to right with a velocity of 2 meters per second. Okay, and it collides with another block of mass 3 kg which is moving in the opposite direction with a velocity of 4 meters per second. I am drawing it on the next slide for all of you. Repeating, I am drawing this question on the next slide for all of you. So please do not ask me to go back again and again. Okay. Question ka first part is what we will be solving. If the collision is perfectly elastic, find their velocities after the collision. If the collision is perfectly elastic, that means if E is equal to 1, find out V1 and V2. So this is the situation in front of you all. Precisely questions written in the mathematical form. So everyone, body 1, 5 kg, moving with 2 meters per second. Body 2, 3 kg, moving with 4 meters per second. They eventually are going to collide here. And after that, what will happen to their velocities? We don't know whether they both will go to the left side, they both will go to the right side, they both will stop. We don't know. They will definitely separate out. They will not stick to each other. That is what we are sure. Because the collision is perfectly elastic. Okay. So formula for V1 is in front of you all. So I'll simplify for you. M1 is 5, M2 is 3, 5 plus 3. U1 का value is 2. ध्यान देना, positive U, because this direction is positive, this direction is negative. Plus 2 times M2, that is 3, divided by 5 plus 3, and velocity, please pay attention, I'm writing minus 4. Why minus 4? Because the direction of motion of 3 kg body is negative. So this is 2 by 8 into 2 plus, minus it will be because of this minus sign. This is 6 by 8 into 4. So what do I have? 4 by 8, or I can say it is 4 minus 24 by 8. They both have the same denominator. This is 4 by 8, this is 24 by 8. So this is minus 20 by 8, or minus 10 by 4, or minus 2.5 meters per second. This is V1. That means after collision, 5 kg body goes with 2.5 meters per second to the left side. That's what happens to it. Minus sign taken care in the direction already. So this is V1. Okay guys, direct application of formula. Now we'll find out V2. Formula for V2, M2 minus M1 upon M1 plus M2 into U2, and then 2M1 upon M1 plus M2 into U1. Okay, so M2 is 3, M1 is 5, divided by 3 plus 5, that is 8. U2 ka value is minus 4. Okay, and 2 times M1 upon M1 plus M2 into 2. So this comes out to be minus 2 minus 4 by 8 plus 4 5s are 20 by 8. So you can see that this is minus 8 by 8 plus 20 by 8. U2 is minus 4. Minus 4 minus 4. So this is going right. So this looks like minus 1 plus 20 by 8 was 2.5. So this is coming out to be, my bad. One mistake. This will become plus. Yes, that will become plus, right? Plus 8. Correct. This will become plus, minus. So this is 3.5 meters per second. So after collision, body B of 3 kg will go to the right hand side with velocity 3.5 meters per second. Okay, guys? This was the first part of the question. Now, read the second part of the question. The second part of the question says, if value of E is 0.6, then determine their velocity. So we have not even studied about the partially elastic case, but we will still be able to solve the question without even studying it. See how do we do it. So guys, in this one, you just have to think of the two things always. The first one, the situation is same. The solution will require two situations to be always taken into account. The first is M1 U1 plus M2 U2 equal to M1 plus M2. And the second is E will be equal to V2 minus V1 upon U1 minus U2. These are the two things that will help you always solve the questions in collision. So what is M1? It is 5. What is U1? It is 2. What is M2? It is 3. What is U2? It is minus 4. 5 into 2, 3 into 4, but with a minus sign. And this will be, my bad, in the flow I forgot to mention velocities, M1 V1 plus M2 V2. So M1 is 5, V1 we do not know, M2 is 3, V2 we do not know. Okay? So simplify this, 10 minus 12 equal to 5 V1 plus 3 V2. So 5 V1 plus 3 V2 is equal to minus 2. This is my equation number 1. From here, value of E has been given to us as 6 by 10 or 0.6. So I write it as 6 by 10 V2 we do not know, V1 we do not know, U1 is 2 and U2 is -4. Okay, and 3 by 10 can be written as, sorry, 6 by 10 can be written as 3 by 5. Okay guys, so what do I have here is V2 minus V1 upon 2 plus 4, that is 6, equal to 3 by 5. So my equation comes out to be 5V2 minus 5V1 equal to 18. Now I have two equations and I have two unknowns, V1 and V2. Simplify करेंगे, दोनों equations solve करेंगे. Okay guys, so let's carry on with the two equations, 5V1 plus 3V2. Okay, 5V1 plus 3V2 equal to -2 and 5V2 minus 5V1 equal to 18. 5V2 minus 5V1 equal to 18. If you will add these two equations, you can see that minus 5V1 and plus 5V1 will be cancelled, and 5V2 plus 3V2 becomes 8V2. This becomes 16. V2 comes out to be 16 by 8, 2 meters per second. That is velocity of 3 kg body after collision. And from here, any of these two you can solve. 5V1 will be equal to -2 minus 3V2. So that is -2 minus 3 into 2. So that's -2 minus 6 is -8. So V1 is equal to -8 by 5, which is 1.6 minus 1.6 meters per second. That's our answer. Maths after that. Right, everyone? Hope you guys understood. Okay. Mr. Aditya Sharma, you are in my hit list today, by the way. Mr. Aditya Sharma, आप मेरी हिट लिस्ट में हो आज, याद रखना. मैं पहले भी बोल चुका हूँ, आदित्य शर्मा शायद से मेरी क्लास में नया स्टूडेंट है ना आदित्य? Looks like you're a new student in my class today. Nihal Tapsi, you can't use that equation here in the part 2. In the second question, here you cannot use that equation. What you are suggesting? Okay, guys. Now, what exactly we did is this. What we did in the previous question is this only. Pay attention now. The question that you just now solved with me, this one, where E was not equal to 0, it was not equal to 1. What we just now did is actually partially elastic collision or inelastic collision. Okay. So what happened here? E ka value jo hai, it is between 0 and 1. Because of that, I'm about to show you an alternate tarika which you will have to memorize if you want to. If you want to, it is perfectly acceptable if you do not memorize it. This is the equation that you will get. Nihal, you were asking me about that thing. In the question part 2, part B, this is what is being done. We have done E equal to V2 minus V1 upon U1 minus U2 equal to 0.6. That's what we did there in the question. So what this formula that you see, guys, these two formulas, they are actually coming from the two equations: law of conservation of momentum and coefficient of restitution. कितने लोग याद करना चाहते हैं वो याद करें. Those who do not want to memorize, totally acceptable. No need to memorize. Okay. But how will you solve the question? By writing equation 1, by writing equation 2, you will be able to solve the question. Okay. Happy? By the way, if you memorize this, you just have to put E ka value as 1. You get the elastic collision wala answers also. Okay. Yes, Tushar. तुम किसकी बात कर रहे हो? Are you speaking about this one? नहीं लगा सकते, नहीं लगा सकते, नहीं लगा सकते क्योंकि E का वैल्यू 1 नहीं है. Only in the case of E equal to 1, perfectly elastic collision होना चाहिए. Then only, otherwise मैं इक्वेशन लगाता ही ना, फिर तो मैं डायरेक्टली फॉर्मूला यूज करता ना. फिर तो मेरे लिए और आसान होता अगर E का वैल्यू 1 होता तो मैं डायरेक्टली ये फॉर्मूला यूज करता जो डिराइव किए थे. Got it? Okay. Guys, are you all interested in solving some quiz questions? A question for all of you. Finally, finally question for all of you. Those who are not interested, they can just wait and watch. इसमें कोई फॉर्मूला नहीं है, ये अभी जो सॉल्व किया वो तरीका है. ठीक है. So, अच्छा चलो, this I am leaving for you guys as homework. ये homework की तरह छोड़ रहा हूँ, but I will tell you what you have to do. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2, and दूसरा E equal to V2 minus V1 upon U1 minus V2. ये दो चीजें लगा के solve करना है इसको. Okay? Yes. Similar I have solved already. Yes. Now quiz questions. Everyone, quiz questions. Quiz questions will be relatively easier. Okay? Quiz questions are relatively easier. Easy questions giving directly easy questions to all of you. Two balls, each of mass 5 kg, moving in opposite direction with equal speeds of 5 meters per second. They collide head on with each other, and you have to find out if their collision is perfectly elastic. What will be the velocity of this ball A? This ball A, which is moving 5 meters per second. After collision, what will be its velocity? Giving you 30 seconds, and the time starts in 3, 2, and 1. Why have I given only 30 seconds? Because I want you people to remember a special case. Because I want you people to remember a special case. When the objects have the same mass, what happens to them? The velocities will be exchanged. Exchange का मतलब होता है vectors को एक दूसरे को दे दो. Provide vectors to each other. That means what? After collision, ball A will move to the left with 5 meters per second, which was the velocity of B, and ball B will move to the right with 5 meters per second, which is the velocity of A. The question is asking for A. What is the correct answer? Now its final velocity has become minus 5 meters per second. That's why the correct answer is this. Okay. Good. Next one. A 0.1 kg ball makes an elastic head-on collision with a ball of unknown mass. Okay. So 0.1 kg ball head-on collision with a ball of unknown mass whose initial velocity is 0. B का initial velocity is 0. If 0.1 kg ball rebounds with 1/3 of its original speed, what is the mass of the other ball? Just hold on. Perfectly elastic है क्या? Okay. Perfectly elastic collision. Oh, elastic बोला है, sorry. It is elastic collision, guys. V1, I hope you guys have written the formula. M1 minus M2 upon m1 plus m2 into u1 plus 2 times m2 u2 upon m1 plus m2. This is said that v1 is minus of u by 3. m1 का value is given, m2 पता लगाना है, giving you all 90 seconds and your time starts in 3, 2 and 1. सब कुछ कर दिया मैंने, तुम्हें कुछ नहीं करना. You guys have to do nothing. It's around 30 seconds remaining. Last 5 seconds, everyone. Okay. Okay, and the time is up. So everything was given. First of all, u2 का value is 0. So things become even more simpler. Okay? So you just have to put u1 as minus u by 3. I've given that also because it is rebounding. It is rebounding, that's why. So when it rebounds, it becomes minus u by 3. Everything else, simplify, multiply, simplify, get the value. Only mathematical question. 0.2 kg. Okay? m1 का value 0.1, m2 का value do not know. Put up both the values, cross multiply, simplify, and done. Okay? Chalo, last question. 3 balls A, B, and C of same mass are placed on a frictionless horizontal plane. These are 3 identical balls placed on a frictionless surface. Okay, guys? And ball A is initially given a velocity. Ball B and C are initially at rest. The question says that eventually, whatever happens, whoever collides, whatever be the situation that you'll have to predict, you have to finally find out. You have to find out the final velocities of all the 3 balls. Okay, obviously A collides with B, then something you'll have to think of. Then C will also be brought into the picture. Giving you guys 45 seconds, and the time starts in 3, 2, and 1. Think smartly. All the bodies are of equal mass and colliding elastically. Okay. Last 10 seconds now, everyone. Okay. Okay, time's up. What do you say, guys? Easy, hai? Ball A collides with B, velocity exchange. So A come to rest, B moves with B. B moves with that velocity. So A come to rest, B starts to move with a velocity u, and then C. And finally, B collides with C, and finally C moves. You can also think of it from law of conservation of momentum, everybody. Initially, the momentum is only with ball A, okay? And finally, the momentum will only be with ball C. That's why, okay? Good, awesome. Kuch aur examples, we will do them next time. Okay, not a problem. Yes. विशेष ब्रह्म भट्ट, तुम्हारा नाम हमेशा के लिए वहां पे सुनहरे अक्षर, सॉरी, काले अक्षरों में लिखा गया है. Sir, in real life, this will happen or not? What will happen or not? Yes, 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 yes. Hello? Three cases we're talking. No, I didn't say case 1 is only important. Keeping the result of case 1 in mind is more important. Keeping this result in mind is more important. Because case 2 you did not understand or what? Either I'm not listening to you properly or your voice is breaking in between. Can you read this part? What is written here? If there is a stationary truck and you throw a ball at the truck, what will happen to truck? So that's why it was initially at rest, later also at rest. Read this. What will happen to truck? That's why its velocity remains unchanged. And what will happen to the ball? Very fast. That's what happens. The entire game is of force and energy only. Obviously. Right? Okay? Okay, yeah. Sorry guys, I forgot to show this. Yes. Can we eat now? You want to eat something from the screen? Please go ahead. Congratulations, all of you guys. Okay. I'm Elon Musk in disguise. Nobody cares. Elon Musk and Mark Zuckerberg. Sorry, fake Elon Musk and fake Zuckerberg. We don't care. What fake name you're carrying, we don't care. I know some people are liking the update, some people are not liking the update. Okay. Sir, have you had dinner? Yes, I had dinner at 8 o'clock. That's why I joined around 2-3 minutes late. These velocity formula can only be used for elastic collisions. this formula can be used only for elastic collision because it comes when E is equal to 1. Okay. और बोलो. Class teachers, once you are done with your doubts, you can leave the class. Sir, what was it dinner? Seriously? अरे ले मेरे भाई, रॉकेट भी ले ले यार. घर लेके जाना रॉकेट को दिवाली पे. Okay, happy? पहुंच गए चांद पे. Everyone on cloud 9. Sir, general query non academic, you'll have to wait. Arshad, you'll have to wait. विशेष ब्रह्म भट्ट, अब तुम खुद से ट्राई करो उस सवाल को. आज जो पढ़ाया है उसके बेसिस पे. ठीक है. विशेष कुमार. यस समझ गया. यस. Come again? If they what? Means you are saying this is what happens. This and say this is what is happening. This fellow is going like this and this fellow is going like this. Right? You want it to collide here, right? And then this is the situation. What do you say? Do you think they still will continue to move along the direction which they originally were moving in? Obviously not, because what will happen now, if you try to look at their point of contact, draw a tangent over there. Okay? Draw the tangent at the point of contact. And the force on both of them will act perpendicular to this point of contact. Like this. Now you can see that these two forces and the velocities are not in the same line. So definitely they both will move basically not in that direction, they will be in under oblique collision now. This guy will go like this and this guy will go like this. Not necessary. Not necessary. If one object is coming like this, the other one is coming like this. Both of them of same size, coming, colliding here. Then also. Have you ever played carrom board? Try to hit one coin with the other one. They always move in the random directions, which is basically oblique collision. Two-dimensional collision is called oblique collision. It can be. It is, in fact. For most of the object, it is microscopic level. Yes, you are. Wait. एक मिनट. Okay. ठीक है, विशेष ब्रह्म भट्ट. Because you do not happen to listen to what I say, that's why I have to write down things for you. Okay. Cool. And if it is not from today's topic, then to any which way I'm not answering it. Okay. You should know that. If it is not from today's topic, then to any which way no way I'm answering it today. वापस छप जाएगा और आपकी बार मैं हटाऊंगा नहीं नाम आएगा तो. Yes, संबंधिता. Yes, just a second. After collision, I know some people are saying how do you get to see the slide number? That is really challenging. Wait a minute. This is not up. This is the slide. Ha. That pendulum kind of situation. That is perfectly elastic. That is almost a perfectly elastic collision, and that is what is happening there. Of equal. विशेष ब्रह्म भट्ट, get your microphone connected. I want to speak to you. I want to speak to you. मैं तुम्हारे डाउट्स सारे क्लियर करता हूँ. जरा माइक्रोफोन लेके आओ, कनेक्ट करो. तो मुझे बताओ कि वेदांतु सब्सक्रिप्शन प्लान में क्या बताया क्या नहीं. आओ फिर वेदांतु सब्सक्रिप्शन प्लान में भले जो भी बताया हो, आज सारे डाउट्स क्लियर करूंगा. इनफैक्ट 10 स्टैंडर्ड तक के डाउट लेके आओ आज तो. यस, समझ गया. कैरी ऑन. Finally, that's okay. You guys are more than prepared. नहीं हो रहा है ना वो, इसीलिए तो मैं 1 घंटा में सेशन इसीलिए तो पढ़ाता हूँ ताकि हमेशा हर बार गाइडेंस दे सकूँ. सीरियसली आई एम नॉट द वन हु हैज कैंसल इट. आई विल. ठीक है, करेक्ट. ठीक है, ओके, चलो बाय. सबको अनम्यूट करेंगे यार, लोड मत लो तुम लोग. विशेष ब्रह्म भट्ट से बात करने का मन कर रहा है अभी मेरा सबसे ज्यादा. यस मार्क, व्हाट्स योर नेम? व्हाट्स योर रियल नेम? Parshan, oh that's you. Okay, tell me. Uh-huh. Uh-huh. So same doubt was asked by someone else also. I said, in fact, Vishesh Brahma Bhatt only asked this question. Okay, so if m1 is very small, if it is a bullet and going very fast, and the object in front is wood, then definitely it will pierce through it. But if m1 is a thermocol piece, and it is going and hitting, what object it is hitting, what is the nature of the object, it will depend upon that. It can penetrate, but will it come out or not will depend on many factors. How thick that object is in which you are penetrating the object, right? How strong that object is. So definitely possibilities there, but you cannot say it is always going to happen. You cannot say it will never happen. It depends upon case. Come again. What? Uh-huh. We are assuming the colliding bodies are also frictionless. If there will be friction, then actually it will become even more complex kind of situation, which is right now not in the domain of our knowledge. That's it. Practically, definitely friction can be there or will be there in fact. Okay. 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 Microphone is not working. Vishesh, microphone is not working. बोलो यार, तुमने क्रिकेट खेला है प्लास्टिक बॉल से? जब हम क्रिकेट खेलते हैं प्लास्टिक बॉल से, तो बहुत बार बॉल जो है वो थोड़ा सा आउट ऑफ शेप हो जाती है खेलने के बाद या खेलते खेलते, पर बॉल कभी भी बैट से चिपकती नहीं है। तो उसे कहते हैं परफेक्टली पार्शियली इलास्टिक कोलिजन केस, जहाँ पे बॉल चिपकी भी नहीं बैट से और अलग भी हुई, लेकिन अलग होने पर भी अपनी शेप को 100% रीगेन नहीं कर पाई। इनफैक्ट जो भी हम क्रिकेट मैच देखते हैं, उन सब में थोड़े ओवर्स के बाद में बॉल को बदला जाता है। क्यों? क्योंकि बॉल का शेप बिगड़ जाता है। बॉल का शेप बिगड़ना इज बेसिकली डिफॉर्मेशन, एंड दैट टाइप ऑफ कोलिजन इज प्रैक्टिकल कोलिजन एंड पार्शियली इलास्टिक कोलिजन। जो इलास्टिक है वही फुल्ली इलास्टिक है, वही कंप्लीटली इलास्टिक कोलिजन केस है। बिल्कुल हाँ, उसमें रीगेन हो जाएगा पूरा। डेफिनेटली एक्स्ट्रा पढ़ना ही पड़ेगा, डेफिनेटली एक्स्ट्रा पढ़ना ही पड़ेगा, बैकलॉग अदरवाइज कैसे कवर होगा? दोनों पैरेलली करना चाहिए फिलहाल, तो थोड़ा थोड़ा पहले वाला बैकलॉग भी साथ में चलना चाहिए, क्योंकि पहले के जो चैप्टर्स हैं उनके कॉन्सेप्ट अभी आगे यूज होते चले जाएंगे। दैट इज व्हाई अगर तुम पहले के चैप्टर बिल्कुल छोड़ दोगे तो अभी की चीजें समझ में नहीं आएंगी। ऑलरेडी टेक टीम हैज बीन गिवन द फीडबैक बाय द टीचर्स, डोंट वरी, हो जाएगा वो करेक्शन। जो भी चीजें हैं जो कभी-कभी टेस्टिंग में आती हैं, गड़बड़ होती है, फीडबैक मिलते हैं, दे चेंज इट। ओके ओके नाइस। यस विशेष, कैन यू प्लीज स्पीक अ बिट लाउडर? Yes, yes, Vishesh. Point number one. Point number one. If I will keep on taking the doubts from your previous chapters, I will not be able to teach the present situation. Listen to me. Listen to me. Am I the person who is responsible? Am I the person who is responsible for that? Am I the person responsible for you not getting answers from the doubt app? Tell me yes or no first. You are not audible, Vishesh. You are not audible at the moment. Yes. Tell me. Yes or no? If you are not getting an answer from a doubt app, am I responsible for it first of all? Am I responsible for it? Then the arrogance in the chat box is not acceptable. The arrogance in the chat box is not acceptable in my class. There is an email ID vk@vedantu.com. There is a number. Speak to your Sam. Speak to your Sam. Come again. Come again. Your Sam is not responding to you. Tell me the name of your Sam. Tell me the name of your Sam. Give the number. Give the number right now. Give the number right now. Sam's number. Give me right now. 63 359 076. Seema is the name of your Sam. Okay. I will speak to your Sam and figure out what is happening. Whose head? Seema is not responding, as in your Sam is not responding to your doubts. This is a phone conversation or a WhatsApp conversation? WhatsApp conversation, you don't have to explain. If it is a WhatsApp conversation, I'll get the screenshots, I'll speak to your Sam, I'll figure out what is the word and what is you're conveying, what is actually the situation. Okay? And remember, in my class, I take the doubts, the first priority is always the current class. You carry this rudeness in my class, I will never answer to your questions. You can change the batch also. You can change the batch also. You can write an email asking for a teacher change also. You can ask, that Sui sir is the rudest person. He doesn't teach properly. I don't want to be taught to him. Please change my batch. In these words, you can write down. Exactly. So if you think that I'm responsible for that, then only show me the rudeness in the chat box. I do not know what other two teachers do, but I know that for any other batch, I do not spend 1 extra hour after the class. If you will tell me that during my enrollment, I was told that the class, I was not told that later sessions the doubts will not be taken, then they must have told you that class duration is only 2 hours. Nobody can force me to take a class over 2 hours. In fact, my HOD has told me to end the class at exactly 10 o'clock. I am telling you and I'm telling everybody, if the world works with the rudeness, then nobody will get the solutions. I can actually make the rule right now that from henceforth I will end the class 10 o'clock whether the doubts are there or not. Do you understand my situation? You are the only one thinking about yourself. I have in front of me over 1,000 students. If I will think about me, I will stop the class at 10 o'clock. If I will think about me, I'm thinking about every single student. That is why. If it is not about you guys, then why would I spend another 1 hour after the class? It is not me who has stopped you earlier from asking the doubt. Please stop giving me reasons which are not acceptable. Have I said, Vishesh, you are not allowed to ask the doubts in my previous class? Have I? Then how can you bring the reasons which are not genuine or which are not usually logical? Exactly. Again, you are going to the same circle. I can always say that it is not me responsible for those things. You are expressing it, but there is a way you express your problems, your concerns. There have been times where other students have also expressed the similar problems, and not me. The class teachers themselves have helped them out. But you have to remember that the people you are asking your concerns with, they are not the reason behind your problem. So if you're expressing your concern to the person who's not the reason for it, you have to be respectful, if not anything else. Getting? After that, what you said is what I said. Exactly. And I said you have to ask these doubts in the doubt app. Where was I wrong? Have you seen me? Have you seen me not saying this to other students? Is that a favor on me? That is why the doubt app is there. That is why the doubt app. And that's what I'm saying. That I told you the entire process. Now you're making me go back to that again. I have taken your SAM's number for a reason. Do you understand? I have taken your SAM's number for a reason because I want to speak to that person. If that person is not helping you out, then that person is responsible. No. I'm not asking you about the explanation part of it. I will speak to your SAM. I will understand the situation. I will tell her to get your problem sorted, and if she has given you any of those responses which you are telling me, then definitely we will take an action. I will forward it to the HODs. But you will have to understand that all the problems cannot be solved right now. They will require time for me to also investigate, for others also to investigate. What do you want me to do right now? You tell me that. You will have to wait till the end of the class. You will be the last person I'll be taking the doubt today. Will that be acceptable? Please wait. Okay, what else? और कौन है जिसको म्यूट होना है, बात करनी है? यस अर्शद. अरे तो पहले एकेडमिक डाउट्स होंगे, उसके बाद नॉन एकेडमिक. हाँ. विहान, ओनली डाउट्स. ओके, और नॉन एकेडमिक का तो वेट करना पड़ेगा. नेक्स्ट क्लास में बात करते हैं. ओके ओके ओके, वेलकम. हु एल्स? अरे डरो मत यार, पूछो, तुम्हारे डाउट्स पूछो. डाउट्स को मैं कभी मना नहीं करता हूँ, स्पेशली जो मैंने आज पढ़ा है उसके डाउट्स मैं 100% अभी क्लियर करूंगा. Don't be afraid, don't be afraid. You know me, you all know me. And that is why I'm so on the face. I'm not fake. I'm on the face. Realizing that this is getting recorded as well. Still. मनन बात करते हैं. Good question. लक्ष्य is 0. Huh? Yes, sure. So you see that final velocity of the two objects is going to be same. They are sticking together. They both are sticking together, so definitely their final velocity, that means v1 is equal to v2. You realize that u1 and u2 is the initial velocity, v1 and v2 are the final velocities, right? So v1 and v2 are equal. So what is v1 minus v2 then? If I put v2 here, will be 0, right? And what is coefficient of restitution? It is v1 minus v2 upon v1 plus v2. Stop writing anything in the chat box, Vishesh. Humble request to you, not to you. I'm talking to Vishesh. And this is, sorry, v2 minus v1 upon u1 minus u2. So will this value come out to be 0 then? Yeah, because numerator will become 0. That's why the value. No. E is greater than 0 and less than 1. That's basically partially elastic collision, where the two extreme cases are not happening. E is neither 0 nor 1. It is something between 0 and 1, like the questions that we solved here. E equal to 0.6. So that is the case where your bodies are colliding. They are not even sticking to each other, but they are not even 100% regaining their shape after the collision. So the collision is called partially elastic. Okay? And I hope that you guys. Anyway, so thank you. Okay, bye-bye. Can two bodies in perfectly inelastic collision after some time be inelastic or inelastic collision? आज तक ऐसा हुआ तो नहीं है, पर इलास्टिक के बाद इनेलास्टिक हो सकता है, बट नॉट विद द सेम बॉडी. सादिक, हो तो सकता है, सिचुएशंस पे है, पॉसिबिलिटी. अभी तक मैंने आज तक कोई क्वेश्चन वैसा देखा नहीं है, पर हो तो सकता ही है. Okay, Vihan, bye. Sir, one question won't be the concern of an entire JEE prep. Lol. It's all about possibilities. Yes, sir, that is what it is. That's what you try to study. आज हर्ष सर ने YT पे सेशन लिया था JEE सॉल्विंग का. हाँ, क्यों, क्या हो गया? तो ले ही रहना, हर्ष सर तो सेशन ले रहे हैं YouTube पे. Thank you, Samadhita. So last question we did, does it happen in real? What was the last question we did? This one? No. Practically not happens. It does not happen practically. Nihal, these are all, see, जहाँ perfectly elastic collision हो गया ना, वो केस सिर्फ हम theoretically study कर रहे हैं. It does not happen practically. Wait, Manan, wait. हाँ, अभी ले लेंगे, I'm sure. Actually, I tell you, Harsh sir is actually on leave. जितना मुझे पता है, he's actually on leave, but because JEE papers are going on, that's why still being on leave, he is discussing the papers. So that's actually very great of him. So I guess he'll be taking sessions back on Monday. Okay, Ami Vaishnav? Yeah. यार ये बंदा तो कुछ और ही बोल रहा है, मार्क जुकरबर्ग, कि उसका सैम बदल दिया. और कोई है इस सेशन के डाउट्स वाला? किधर गया अभी विशेष? आ जाओ भाई, तुम्हारा डाउट ले आओ. विशेष नहीं, फर्स्ट हमेशा एकेडमिक डाउट्स, फिर उसके बाद में नॉन एकेडमिक डाउट्स. मनन चौधरी, 2 मिनट रुक जाओ उसका सवाल सॉल्व करने को यार. ओके हर्षन, विशेष सवाल पूछो ना बेटा जल्दी. हाँ, अभी रुको, मुझे सवाल को हाईलाइट करने दो. there are blocks 1 kg and another 10 kg. That 5 kg block is placed on 10 kg. Okay, ये है 10 kg, ये है 5 kg and 200 न्यूटन is applied to 10 kg. ठीक है, 200 न्यूटन का फोर्स लगाया है. Okay, and the coefficient of friction between 5 and 10 kg is 0.5. okay, यहाँ पे म्यू का वैल्यू दिया है 0.5. बहुत बढ़िया. Okay, and 10 kg is the coefficient between 5 kg and 10 kg is 0.5 and the surface and 10 kg is also 0.5. Okay, तो सेम म्यू वैल्यूज है बेसिकली. 0.5 यहाँ भी सेम है, राइट? सही बोल रहा हूँ मैं? बाय अनुष्का, गुड नाइट. दे आर नॉट मूविंग टुगेदर. फाइंड एक्सेलरेशन एंड फ्रिक्शन फोर्सेस. ये ऐसा क्यों लग रहा है कि बुक की लैंग्वेज नहीं है, तुम्हारी लैंग्वेज है सिर्फ. एंड दे आर नॉट मूविंग टुगेदर, सो फाइंड द एक्सेलरेशन एंड फ्रिक्शन फोर्सेस. क्वेश्चन सही है अभी तक? तो नहीं समझ रहा. विशेष, हैव आई ड्रॉन द डायग्राम? व्हाट वाज इट? ठीक है. हमें क्या पूछा है? एक तो तुमने बोला एक्सेलरेशन निकालना है ना दोनों के, और फ्रिक्शन फोर्स कितने पता लगाना है. करेक्ट, राइट 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 राइट, परफेक्ट. ओके, तो सबसे पहले तो उस ब्लॉक का फ्री बॉडी डायग्राम बनाते हैं. विशेष, डू यू अंडरस्टैंड हिंदी? गुड. तो पहले उस ब्लॉक का फ्री बॉडी डायग्राम बनाएंगे जिस पे फोर्स लगाया है. सो दिस इज 200 न्यूटन फोर्स. तो इसको दोनों जगह से फोर्स ऑफ फ्रिक्शन मिलेगा. नीचे वाली सरफेस से भी मिलेगा, ऊपर वाली सरफेस से भी मिलेगा. तो मान लो यहाँ से F1 मिलता है और यहाँ से F2 मिलता है, और ऊपर वाली जो बॉडी है उसका फ्री बॉडी डायग्राम बनाओगे 5 kg बॉडी, उसको फ्रिक्शन फोर्स F2 मिलेगा ऊपर की तरफ. ओके, यस, बाय बोली. सो यहाँ पे जो नॉर्मल फोर्स है वो 5g के बराबर होगा. ओके, बाय 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 बाय. विशेष, दिस इज 5g, करेक्ट? रोशन, वेट फॉर सम टाइम, यू हैव अ काउंटिंग आउट, वेट फॉर सम टाइम. सो F2 विल बी इक्वल टू म्यू इनटू n. इसको n1 बोल देते हैं, एंड दैट इज 0.5 मतलब हाफ. और नॉर्मल n1 का वैल्यू 5g के बराबर होगा, तो 50 कर देते हैं, तो F2 का वैल्यू आ गया 25 न्यूटन. F2 हो गया, ठीक है. अब F1 भी निकाल लेंगे. F1 कैसे निकालेंगे? F1 होगा म्यू इनटू n2, और n2 जो है दैट इज बेसिकली द नॉर्मल फोर्स अप्लाइड बाय द ग्राउंड, व्हिच इज इक्वल टू 5 + 10g. डू यू एग्री विशेष? 15 × 10 हो जाएगा वो, तो 150/2 75. तो ये हो गया फ्रिक्शन फ्रॉम द ग्राउंड. दोनों फ्रिक्शन मिल गए, आधा क्वेश्चन हो गया. अरे यार, दोनों बॉडीज का वेट लगेगा ना नीचे ग्राउंड को, तो दोनों बॉडीज का फोर्स फील होगा ना. 5 + 10 kg मतलब यहाँ वेइंग मशीन रखूंगा तो दोनों बॉडीज का वेट होगा, इसलिए. ओके, अब एक्सेलरेशन निकालते हैं. इसका एक्सेलरेशन a1, इसका एक्सेलरेशन a2. अगले स्लाइड पे चलते हैं. अच्छा भाई, डुप्लीकेटेड द स्लाइड. ठीक है, चलो. अरे यार, ओके. सो a1 क्या होगा? द ओनली फोर्स व्हिच इज ड्राइविंग इट इज F2. 200 - 25 - 27, 27 नहीं 75. पहले a1 निकाल रहा हूँ मैं, पहले a1 निकाल रहा हूँ. तो a1 हो जाएगा F2/m1. F2 आया 25 kg और मास कितना है 5, तो ये हुआ 5 मीटर पर सेकंड स्क्वायर. फिर a2 निकालो. a2 क्या होगा? 200 फोर्स माइनस F1 माइनस F2 डिवाइडेड बाय m2. ये आया समझ में विशेष? ड्राइविंग फोर्स, अपोजिंग फोर्स, करेक्ट? वेट अ सेकंड. सो 200 माइनस 25 और 75 मिला के 100 डिवाइडेड बाय मास दैट इज 10. तो 200 और 100 कितने हो गए मिला के? कितने हुए मिला के? कितने हुए? 100/10. ये आया 10 मीटर पर सेकंड स्क्वायर. 10 ही तो आया. हाँ ठीक है, मैं अभी करता हूँ, म्यूट करता हूँ. 10 ही आ रहा है दोस्त विशेष. 5 और 10 नहीं, ये करेक्ट अप्रोच है विशेष. दिस इज द करेक्ट अप्रोच. ठीक है, दिस इज द करेक्ट आंसर. ओके, तो वेट यार, निहाल मुझे जरा उससे विशेष आर वी डन? ओके, कूल. चलो विशेष, आर यू ऑन टेलीग्राम? विशेष, आर यू ऑन टेलीग्राम? ओके, सो इंस्टॉल टेलीग्राम ऐप. ओके, इंस्टॉल टेलीग्राम ऐप एंड डू वन थिंग. आई एम शेयरिंग यू माय टेलीग्राम आईडी, दिस NJOY_SURI. नो, किसी के भी फोन से, अपने पेरेंट्स के फोन से टेलीग्राम डाउनलोड करना, टेलीग्राम को इंस्टॉल करना, और ये जो मैंने आईडी भेजा है टेलीग्राम ऐप पे, इस पे जाके मुझे वो स्क्रीनशॉट्स भेजना जो तुम्हारे सैम के साथ तुम्हारी कन्वर्सेशन है, वो स्क्रीनशॉट मुझे यहाँ पे भेज देना. ठीक है, ओके, डू दैट ASAP, जितना जल्दी करोगे उतना अच्छा. मनन, किधर गए तुम? ओके विशेष, गुड नाइट. रोशन यार, ठीक है यार, एक मिनट. मनन, होल्ड ऑन अ सेकंड, पहले रोशन का डाउट ले लेता हूं. में सर, इन केस ऑफ एयर हॉकी, व्हेन वी स्ट्राइक स्ट्राइकर अ फोर्स फ्रॉम द एयर हॉकी stick, and if both the players are hitting the striker together, each of them, then why their air hockey stick is not moving into the opposite direction? ठीक है सर, in case of air hockey, when we strike striker, striker as in the coin or the one that is in your hand. striker तुम्हारे हाथ में होता है. Okay, coin. So sir, in air hockey, when we strike the coin with the force from what? Air hockey stick. Okay, and if both the players are hitting the coin towards each other, then why their coin is not moving in the opposite? नहीं समझ में नहीं आ रहा मुझे. We are holding the striker. हाँ, मैं क्वेश्चन नहीं समझ पा रहा हूँ कि what exactly are you visualizing them to move in the opposite direction as in what? ओके विशेष, मिल गया, मैसेज मिल गया. ऑसम, आई टेक इट फ्रॉम हियर. अरे उसका माइक्रोफोन नहीं चल रहा ना यार रोशन का, इसीलिए तो प्रॉब्लम है. वरना मैं तो बात करता हूँ, बात करता हूँ. और सिंपलीफाई करके लिखो यार तुम रोशन. तब तक मनन किधर गया? मनन, वेयर आर यू? सर, द फर्स्ट क्वेश्चन वी डिड फॉर फाइंडिंग, हाँ एग्जैक्टली निहाल, क्योंकि वो इलास्टिक कोलिजन था ना, पहले पार्ट में इलास्टिक कोलिजन बोला है, इसलिए किया. ओके अर्शद, ओके अर्शद, आई विल अनम्यूट यू आफ्टर मनन. यस मनन, बोलो. 3 क्या? तीन आइडेंटिकल पेयर्स को हम कनेक्ट करते हैं ऐसे, और फिर क्या उनका सेंटर ऑफ मास निकालने का. तीनों स्फेयर्स ही है ना, तो दिक्कत क्या है? इन तीनों के सेंटर ऑफ मास इक्वल ट्रायंगल में आएंगे, इक्वल ट्रायंगल के तीनों कॉर्नर्स का लोकेशन पता लगाना है, कुछ नहीं। हाँ, तो तीनों स्फेयर्स का सेंटर ऑफ मास है वो इक्वल ट्रायंगल पे आएगा ना, उनके इंडिविजुअल सेंटर ऑफ मास। अरे ठीक है भाई, ये डायग्राम है, और तुम्हारा वो लाइन यहाँ पे है क्या? ऐसा है क्या? ये ऐसा है, यहाँ से है ना ऐसा, और वाई एक्सिस किधर है? पक्का इधर ही है, और रेडियस कितने दिए हुए हैं? हाँ, किसके ऊपर क्या? एक मिनट, ये लाइन इधर है, ठीक है ठीक है, कोई वो तो और भी आसान है फिर, तुम ये बोल रहे हो ना, ये है, और एक ये है, ठीक है, तो ये तो बहुत आसान हो गया यार, ये इक्वल ट्रायंगल बनेगा, वही तो बोल रहा हूँ तुमसे। ये एंगल 60 डिग्री है, इसके कोऑर्डिनेट 0,0, रेडियस आप देखा होगा, तो यार है, तो इसका कोऑर्डिनेट 2r,0 हो गए, और इसके कोऑर्डिनेट तुम अब यार इक्वल ट्रायंगल में अगर तुम ये साइड नहीं पता लगा सकोगे क्या, ये r है, ये 60 डिग्री है, तो ये हो गया आधा डिस्टेंस r, ये तो वैसे भी हाफ होगा, तो ये x कोऑर्डिनेट तो r ही होगा, नहीं r नहीं होगा, सॉरी, r cos 60, हाँ भाई 2r है, और ये 2r है, सॉरी ये 2r है, 2r cos 60, हाँ करेक्ट करेक्ट करेक्ट। नहीं डायग्राम ऐसा बनाया कि इसको ये भी जो है ना, ये वाला साइड इससे टच हो रहा होगा डायग्राम में, ये जो है ना, ये टच हो रहा होगा, तो ये तो इसका x कोऑर्डिनेट r आ जाएगा, और y कोऑर्डिनेट आएगा 2r sin 60, sin 60 का वैल्यू होता है √3/2, मतलब r√3, बस ठीक है, लगाओ m1x1 + m2x2 अपॉन m1 + m2, सॉल्व करो, जल्दी बोलो, फिजिकल एजुकेशन ले लो, लिया पड़ा है तो उसमें डिस्कस क्या करना है, फिजिकल एजुकेशन में कुछ करना ही नहीं होता है, पढ़ना ही पड़ेगा वो तो, स्कूल बदल दो, टास्क में क्वेश्चन जिसका मैं आंसर दे सकूं दोस्त यार ये वो सिचुएशन है जिसमें मैं कुछ कर ही नहीं सकता, 12th में जाके, अभी तो फिलहाल 11th पास करो यार, 12th में जाके बहुत टाइम लगेगा, टेंशन मत लो, ओके बाय। नो आई डोंट हेट दैट सब्जेक्ट, आई फाइंड इट यूजलेस। हाँ रोशन का अर्शद एक मिनट, हाँ तो मैं म्यूट करूंगा अभी, सर लाइक सपोज वी बोथ आर प्लेइंग हॉकी, यू आर नॉट राइट साइड, यू आर ऑन राइट साइड, आई एम ऑन द लेफ्ट साइड, विल हिट द पॉइंट टुवर्ड्स लेफ्ट साइड, दैट इज टुवर्ड्स मी, हाँ ओके, एंड देन व्हाई डजंट योर स्ट्राइकर मूव टुवर्ड्स यू, दैट इज, अरे बिकॉज़ आई एम होल्डिंग इट, बिकॉज़ आई एम होल्डिंग इट, मैं भी तो एक फोर्स लगा रहा हूं, एक्सटर्नल फोर्स, ना 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 ना, ये अगर मैं ऐसे छोड़ दूं मेरे स्ट्राइकर को, अगर मैं मेरे स्ट्राइकर को मेरे हाथ से छोड़ दूंगा तो स्ट्राइकर कॉइन को हिट करेगा, और उसके बाद में वापस आ सकता है, आ भी सकता है, नहीं भी आ सकता है, इट मे कंटिन्यू टू मूव इन द सेम डायरेक्शन। रोशन आया समझ में? यस यस यस, अरशद योर नंबर, यस अरशद, आवाज बहुत कम आ रही, बहुत एको होता है जब भी तुम बात करते हो तो, कुछ समझ नहीं आ रहा तुम क्या बोल रहे हो, हाँ पहले से बेहतर बोलो, अभी क्या बोल रहे, आवाज ही नहीं आ रहा अभी आवाज ही गायब हो गया, माय प्लेजर मनन, माय प्लेजर, बट आई एम आल्सो ह्यूमन बीइंग, मुझे भी गुस्सा आता है, अरे यार ये म्यूट तो हो गया, लेकिन अब इसको क्लोज कैसे करें, आशीष योर माइक्रोफोन इज नॉट वर्किंग, आशीष कुमार, अरशद आवाज नहीं आ रही बच्चा, अब यूजर नॉट प्रेजेंट हो गया, ओके मनन बाय बाय, विशेष आई विल सी व्हाट कैन बी डन, मतलब आई एम नॉट द वन हू डिसाइड्स यार, यू नो दैट, फिर वही चीज पे तुम गलत डिसीजन के पॉइंट ऑफ व्यू से तुम मन में कुछ और पहले से डिसीजन बना के मत सोचो, मैं बात करूंगा, सैम से भी बात करूंगा, और जो तुमने स्क्रीनशॉट भेजे पहले तो मुझे पढ़ना पड़ेगा ऑब्वियसली, एंड देन आई विल फॉरवर्ड इट टू द कंसर्न पीपल इंक्लूडिंग द एचओडीज आल्सो, ठीक है, एंड देन यू विल डेफिनेटली गेट अ कॉल बैक, दैट्स ऑल आई कैन सजेस्ट, मैं सिर्फ इस चीज को आगे पहुंचा दूंगा, मैं तुम्हारी रिक्वेस्ट भी आगे दे दूंगा, ठीक है। सर पॉसिबल टू सी माय सैम, आई विल चेंज माय सैम सडनली बिफोर सीमा मैम, आशीष सर वाज माय सैम, ही वाज वेरी हेल्पफुल बट वेदांत टू चेंज इट, आई आल्सो डिड नॉट रिक्वेस्ट फॉर सैम चेंज, यार वो हो सकता है कि आशीष सर जो है उनके कुछ और कमिटमेंट्स होंगे, मे बी बिकॉज़ ऑफ दैट, ठीक है। यस अर्शद, अभी बोलो अभी बोलो, हाँ और तभी तुम्हारे सैम जो है सीटीज जो है उन्होंने उस प्रॉब्लम को आगे फॉरवर्ड भी किया था, देख, तो तुम ये काम करो, तुम्हारी भी जो प्रॉब्लम है वो अभी मैंने बताया था, नहीं नहीं तुम एक काम करो, तुम्हारा जो भी केस है ना पूरा वो लिख करके मैं तुम्हें भी बोलता हूँ, ये मेरा टेलीग्राम का ये है आईडी, ठीक है, यहाँ पे भेजो, ईमेल भी किए थे ना, तुमने बोला था कि तुम लोगों ने कुछ ईमेल किए थे, तो वो ईमेल के स्क्रीनशॉट्स मुझे भेज देना, है ना, इसमें तो मैं देखता हूँ और केस थोड़ा एक्सप्लेन कर देना, वो ऑडियो एक वॉइस नोट भेज देना मुझे कि सर ये चीजें हुई हैं, विशेष यू आल्सो डू दैट यार, जो भी तुम्हारा प्रॉब्लम है ना वो एक बार मुझे ऑडियो नोट, जैसे हम व्हाट्सएप पे ऑडियो मैसेज भेजते हैं वैसा ही उस पे भेज दो मुझे, ताकि अगर मुझे फॉरवर्ड करना पड़े कंसर्न पीपल को तो सिचुएशन तुम लोगों के ही वर्ड्स में आगे जाए, मेरे वर्ड्स में ना जाए, है ना, चेंज कर दे, हम्म, ठीक है ठीक है, तुम बिल्कुल जो अभी तुम मुझे बोल रहे हो ना, तुम एक तो वो मेल के स्क्रीनशॉट्स मुझे भेज दो, और ये जो कंसर्न तुम मुझे बता रहे हो प्लीज ये मुझे ऑडियो नोट पे भेज दो टेलीग्राम पे, मैं इन दोनों तुम्हारा और विशेष का केस जो है उसे आगे एस्केलेट करवा देता हूँ, ठीक है, तो जो कंफर्टेबल है वो रखो, जिसमें कंफर्टेबल, ठीक है, समझा नहीं, हाँ 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 हाँ, तो कुछ क्वेश्चन पूछने वाले हो, कुछ मैं समझा नहीं एग्जैक्टली। समझ गया। और ये एक्चुअली यूनिक सिचुएशन नहीं है, ये बहुत सारे स्टूडेंट्स के साथ चल रहा है, बहुत सारे स्टूडेंट्स हैं। तो सिर्फ एक ही सजेशन देता हूँ मैं सबको, डू नॉट गिव अप, जस्ट कीप गोइंग, जस्ट कीप गोइंग। ठीक है। आई नो, ये तो मैं खुद एक्सपीरियंस कर चुका हूँ, इसीलिए तो ऑब्वियसली ये तो है। क्या कर सकते हैं, वी आर इंडियंस। द मोर द रूल्स यू अप्लाई ऑन इंडियंस, द मोर दे ट्राई टू मेक इट। आई थिंक तुम लोगों को भी शायद जब भी दिवाली के आसपास का टाइम आएगा ना, तो एक ब्रेक मिलेगा, तब थोड़ा सा बैकलॉग कवर कर पाओगे। ठीक है, कोई बात नहीं। लुक एट मी, तुम्हारे सामने जो बंदा है उसकी क्या सोशल लाइफ है खुद की। ना भैया, कोई सोशल लाइफ नहीं है, सबकी सोशल लाइफ जो है कोरोना ने जीरो कर दिया। तुम एक्सट्रोवर्ट थे, तुम एक्सट्रोवर्ट थे, तो अभी क्या हो गया तुम? ठीक है, ठीक है, कोई बात नहीं, हैंग इन देयर, सिर्फ दैट्स द ओनली थिंग दैट आई विल से। ओके। और वो मत भूलना मुझे, वो ऑडियो बढ़िया, जितना लंबा ऑडियो भेजना, उतना लंबा ऑडियो भेजना मुझे, मैं फॉरवर्ड कर दूंगा आगे। बहुत बढ़िया, गुड। चलो देन, ओके ओके, बाय, गुड नाइट। आशीष कुमार यार, हाँ आशीष हो गया अनम्यूट। गुड इवनिंग आशीष। हाँ हाँ, बोलो ना। मतलब ये क्या मतलब, नहीं समझा, ये बैलेंस करने का मतलब तुम ऐसे वो तीनों की बुक ऐसे संभाल के रखना चाहते हो हाथों में? तो मैं बोलूँगा शायद ये चीज़ें बहुत डिपेंड करेंगी कि तुम बैलेंस करने के लिए करते क्या हो, एज़ इन तुम एग्जैक्टली क्या टारगेट है तुम्हारा कि ये हो जाएगा तो मैं कह सकता हूँ कि तीनों बैलेंस हो गए। मतलब मैं सिंपली बोलता हूँ कि अगर मैंने सिर्फ सेशन रिवाइज कर लिया, वो मेरी डेफिनेशन है बैलेंस हो जाने की, या मैंने उस दिन के बताए हुए सेशन के क्वेश्चन दोबारा से कर लिए तो मेरा बैलेंसिंग हो गया, या मैंने उस दिन के बताए हुए सारे तत्वों के क्वेश्चन कर लिए उस दिन जो सर ने पढ़ाया, उसमें बेस क्या है, डेफिनेशन क्या है, बैलेंस हो गया। मैं बताता हूँ, देखो कैसा है, तुम्हारे पास दिन में जितना भी टाइम एक दिन में है, गिवन डे में टाइम भी हर रोज चेंज होगा तुम्हारी सिचुएशन में। तो किसी दिन शायद तुम्हें ज्यादा टाइम मिल रहा है पढ़ने के लिए, किसी दिन शायद कम भी मिल रहा है, पर्सनल सिचुएशन के अकॉर्डिंग चेंज होती है टाइम की अवेलेबिलिटी। तुम्हें ये देखना है कि आज मुझे तीनों सब्जेक्ट पढ़ने हैं, मेरे पास टाइम कितना है, मान लेते हैं कि चलो रोज के 3 घंटे का टाइम अवेलेबल है और तीनों सब्जेक्ट पढ़ने भी है। ठीक है, अब तुम्हें जो पढ़ना है उसमें तुम्हें रिवाइज भी करना है, और तुम चाहते हो कि तत्व की एक्सरसाइज के क्वेश्चन भी सॉल्व कर लो। ठीक है, यही एक दिन के उसमें यही कर सकोगे, इससे ज्यादा तुम कर भी नहीं पाओगे। ठीक है, तो तत्व में जब तुम पहली बात तो जो भी अवेलेबल चीजें हैं सामने, तीनों सब्जेक्ट की कितनी क्वेश्चन तुम्हें सॉल्व करने के लिए है अवेलेबल। मान लो फिजिक्स में तुम्हारे पास में उस दिन पढ़ाए हुए टॉपिक पे 20 क्वेश्चन है एक्सरसाइज में, और केमिस्ट्री में 40 है, और मैथ्स में मान लो 20 है या 30 है। ठीक है, अब तुम्हें मालूम है कि तीनों सब्जेक्ट को आइडियली मुझे आधा एक एक घंटा देना चाहिए, 1 आवर फॉर फिजिक्स, 1 आवर केमिस्ट्री, 1 आवर मैथ्स। ठीक है, तो अब एक घंटे में डेफिनेटली मैं सारे क्वेश्चन नहीं लगा पाऊंगा रिवीजन के साथ में, पीसीएम के इंडिविजुअली। ठीक है, दैट मीन्स व्हाट, तुम्हें चूज करने पड़ेंगे क्वेश्चंस, जो तरीका मैं हर बार सजेस्ट करता हूँ। अगर मुझे 40 क्वेश्चन सामने है मेरे और मेरे पास टाइम शायद 40 मिनट्स ही है, तो मैं हर एक मिनट में क्वेश्चन नहीं कर पाऊंगा। तो इट इज बेटर कि मैं पहले क्वेश्चन करूँ, उसके बाद 2 क्वेश्चन छोड़ के तीसरा क्वेश्चन या चौथा क्वेश्चन करूँ, फिर 7th क्वेश्चन करूँ, फिर 10th क्वेश्चन करूँ, सो दैट आई गेट द फीलिंग ऑफ कंप्लीशन एंड बैलेंसिंग ऑफ ऑल द 3 सब्जेक्ट्स। उस तरीके से मैं सारी वैरायटी ऑफ क्वेश्चंस भी देख लूंगा और तीनों सब्जेक्ट्स भी कर पाऊंगा। ठीक है, विशेष ब्रह्म भट्ट प्लीज लीव द सेशन नाउ। ठीक है आशीष। क्यों कर रहे हो तुम जेईई के लिए प्रिपेयर? तो यार साइंटिस्ट, अभी तुम आगे जाके, ये तो कुछ भी मोटिवेशन नहीं है जरूरत। जब साइंटिस्ट अपना रिसर्च करते हैं तो उनके सामने तो कोई टारगेट की डेडलाइन भी नहीं होती कि आज हमारी डिस्कवरी हो जाएगी, आज नहीं भी होगी, फिर अपना मोटिवेशन कैसे बना के रखोगे? हाँ, सिर्फ बोल देना कि मुझे साइंटिस्ट बनना इज नॉट इनफ। क्यों बनना है, क्या फर्क पड़ जाएगा अगर नहीं बने साइंटिस्ट तो? ये लिख के दीवार पे लगा दो कि अगर मैं साइंटिस्ट नहीं बना तो मुझे क्या क्या तकलीफें हैं लाइफ में। बोलो मत, सामने लिख के लगा दो। और जब जब मोटिवेशन कम होने लगे ना, बस उस दीवार के सामने जाके खड़े हो जाओ, पढ़ो, फिर अपने आप मोटिवेशन आ जाएगा। ओके, होगा, जरूर होगा, जैसे साइकोलॉजिकल। ओके, गुड नाइट, गुड नाइट। ठीक है मित्रों, शुड वी कॉल इट अ डे, बिकॉज प्रिसाइसली 1 आवर स्ट्रेच हो गया। ठीक है, थैंक यू, गुड नाइट गाइस, बाय।